So hey guys, this is Team 7 and we have built an issue tracker. What you see in front of us is our front-end dashboard. Not exactly the dashboard, it's the login screen. Now, Joshua here will take you through the whole login process where we are using OAuth authentication, which basically authenticates your Trello from your Trello account. You click on that and you authenticate it via Trello, you get the session token and you paste this session token here. Now, before we log in, I would also like to show you that we are storing these OAuth logins in our Supabase, where right now this current session token, which just now showed up in our table. Now, these session tokens are stored in the database, and these expire within 1 day. And if you log in back after a few hours, you're good to go with the same session token. You'll get all your data and the dashboards back. Now, time for us to log in and for Mingjian to explain how the front end works.
Okay. Hey guys, so in the front end on the left hand side, we have different boards, and if you click into one of them, you can see different issues, and they have 3 states. On the right hand side, we have our AI assistant. So we have integrated different model provider. We have Claude and OpenAI. You can do the toggle and change between different providers. In the AI assistance, you can do a lot of things. You can do simple things as list boards, or you can ask it to create some sort of issue or change the state of the issue. At the same time, we integrated with Team9 Slacks, so you can also ask it to announce the modification in the Slack AI demo channel. So Joshua would do this thing and hit send, and we can see the new message pop up in the Slack later. AI demo.
Can you remind me the name of this channel?
Yeah, you don't have to. You don't
Yeah, you
have
don't-
to say
correct.
the full
Yeah,
name. You can just
just
say
hit send.
AI channel.
Slack
AI demo channel.
Yeah, Slack AI channel.
While it's thinking, we do define tools for AI provider to do things so that we don't expose our backend API to AI provider for security reasons.
Okay, so we have introduced a new chat vertical alongside the issue tracker. We used the chat vertical's shared API first and created an implementation package which provides basic messaging operations like send, retrieve, and delete using lightweight in-memory storage for development and testing. Then we integrated Slack through an adapter layer that connects to Team9 Slack client implementation to our shared chat contract. The adapter handles Slack specific behavior internally and while exposing standardized message objects to the rest of the application.
Okay, so now let's go ahead with our Swagger backend API repo. We have all of these endpoints already configured, and we can test each and every endpoint. Let's go ahead with AI health. So right now we can click on execute, and we can see that we have provided a multi-provider support. We have both Claude and Open AI's models, which is the Claude and the GPT model. Now, we can go ahead and go to the execute portion of it. Let's go and try to do the execution of the AI chat. In this, we don't hard code call Anthropic in the route. Both Claude and OpenAI implement the same AI client interface, and the deployed default is AI provider in the environment. So now if we try, if the user comes in and wants to swap to OpenAI and just prompt that, can you please list all boards, you can execute it. You would see that while it's loading, you would see it will return a per provider pro map, so the UI can show the right model name, and also it, as we saw earlier in the other endpoint, and here you can see that it has actually given us a JSON structured output response, given the reply regarding what all the issue boards exists in this session as well as the actions. So this is the structured output and tools that we have done in the multi-client provider authentication in our AI that can swap. And this is one of our backend backend API calls that we are trying to do and trying to test. Now let's go ahead with the Circle CI implementation. So the important thing that we have done is that during the Circle CI pipeline, everything starts with our config.yaml file. Once a commit is pushed to GitHub, Circle CI will run a workflow called CI, and right away there will be 4 jobs that would start in parallel. So we don't wait in line. There is the lint job. We use the Python 3.12 image, the UV sync, then rough. Both rough check and rough format goes ahead in the lint job, as well as the MyPy across all of the workspace packages. And then we have the test job. So we run the PyTest with -m unit or integration or E2E tests, meaning that only tests that we have tagged as unit, integration, or E2E, that will run in the CI. And we set the OTEL SDK disabled, so the test runner isn't trying to export traces to nowhere. And we emit JUnit XML, so Circle CI's tests tab show each case. We emit code coverage to the terminal. We can see that by clicking onto the test. And if we go to the artifacts at the above and we click on the index.html, we can see the coverage report here. And all of this coverage report is then, right now we have around 90.71% of coverage report, and all of this report is then being processed and posted to the CodeCov. You can go ahead to the CodeCov tab, and we can see that for the Homework 3 branch, we have around 90.27% of coverage, and from the Circle CI run, all of these coverage is getting posted to CodeCov, and we can see a beautiful graph there. Coming back to the Circle CI checks, we also have the health check as well as the validate infra check. And once all of these checks are passed, we go ahead with the deployment. So the Terraform job runs, and there is a Docker file that is built, and then the deployment is done to the Google Cloud Service. Josh will explain more about the other steps.
Cool. Yeah, I could take over from here. Just one of our checks before the deploy is just to validate infra, which we're using Terraform to provision our necessary resources and our environment variables for our deployment, our cloud deployment, and that validates our Terraform syntax is valid. And then we deploy with GCP Cloud Run. We specifically, after this is done, this is deploying just all of our code. We apply Terraform locally for any infra changes. And then I'll go to our revision history. This is all of our deployments on Google Cloud with all of our environment variables that we update accordingly. As you can see, we have our OpenAI that we just used, our Claude, and our Trello secrets. And specifically the secrets, those are stored separately in the secrets manager. So nothing is stored in Git control versioning, and doesn't leak anything for security reasons.
Just to add one more point regarding the integration versus E2E integration tests, Josh, could you please go ahead in the Circle CI report? So mostly under test-integration, we prove our component wires together. We try to have the fast API AI routes with overrides, adapter behavior, chat back and swap through registry, that kind of thing. So all of the integration tests covers all of these 4 and 5 components that I just mentioned, and they also use mocks where HTTP would be fragile. Then coming to the E2E tests under tests E2E, this hits the real Trello API when credential exists, like the boards, errors, tool dispatchers against the live data. So there's also an optional probe against a deployed health if you flip an environment variable flag. Otherwise it will skip, so we are not coupled to production uptime. So integration means our stack agrees with itself, and E2E means that the outside world agrees when we turn it on. So that's regarding our integration versus E2E tests.
And just one more second, just to also highlight our Google Cloud Run. This is the same URL that we were interacting with in the backend before, and health does return status okay, and the database that we demoed before is connected. And now all these endpoints we've been hitting, we'll look at it. So Omar.
So lastly, we have the Grafana dashboard where we have all the metrics pertaining to the application and the AI integrations. Here you can see there's HTTP response rate, 95th percentile server latency, the average server latency, and in the tables below where there are graphs where you can see the responses by status code and the 95th percentile latency by the endpoints. You can see there's AI chat and health endpoint, there's AI health, there's auth endpoint, there's boards, etc. Now, as a part of our extra credit, we have also implemented the AI tokens usage and the token estimated costs. As you can see, these last four dashboards, that's what they show, the AI token throughput and the estimated cost per second, and also the average cost per successful request which was sent out. So this is the entire application, all these stacks, everything covered by Team 7. And yeah, that's all.
Thank you.
Thank you.
Thank you.
Thank you.
Yay.